Alright, so the last quiz in Unit 1 is 1.14, and there's 2 lessons that tie into this. And I had a hard time actually kind of separating these lessons out into succinct discussions, because there's so much that overlaps between the two. So, this one will be a little bit of a longer recording, but there's no math. So, we're talking about properties of liquids and solids. Alright, so do this little activity here. We talked about these things way back in Chemistry A, but I bet you can match these up no problem. So now that you've had a chance to look through, pause if you haven't. Oops. That's your liquid. That's your solid. And that's your gas. Gases are unique about the fact that they are compressible and they fill all available space. Solids are unique that they have a definite shape. Liquids are unique that they do fill the shape of the container, but not necessarily the whole container. And they're not compressible. So, just in case the arrows are getting a little confusing, there's your gas, your liquid, your solid. Alright. So, this is what the molecules look like in these different substances. So let's just say all of this is water. Alright? And we've got ice. We've got liquid water. And we have evaporated water. Alright, so this is what the water molecules would look like. Looking at this and kind of like what you see going on, what do you think is going on with the kinetic energy? Alright, if you were saying that, oh, kinetic energy is increasing from left to right, or like gases have lots of kinetic energy and solids have very little, you are spot on. Alright, solids have some kinetic energy, they have to, but these guys will only vibrate just ever so slightly. Alright, liquids vibrate and can kind of slide past each other, but again, still not moving a whole lot. And gases move all over the place. Alright, so your Ke increases as you go to the right in those pictures. Alright, so there are a bunch of factors that determine whether or not a substance is a solid at room temperature, or is a gas, or is a liquid at room temperature. Alright? One thing is what kind of kinetic energy it has. And there's also, you can apply kinetic energy to change what something is. Alright, so if you add kinetic energy, you're going to push the substance towards the gaseous state. Alright, if you remove kinetic energy, then you're going to push the substance back towards the solid state. Alright, so if you give it energy, it'll move around. It'll eventually move around so much that it's like a gas. If you remove that energy, it'll stop moving, or not totally stop, but slow down enough so that all it's doing is just kind of vibrating a little bit and become back to a solid. So if you want to melt something, so go from solid to liquid, what do you do with kinetic energy? I hope you are saying add more or increase that kinetic energy. So that's how you're going to melt something. So other things that determine your state at room temperature is the strength of intermolecular forces. So if you remember, we talked about this in Unit 4 in Chemistry A, molecules, neighboring molecules, can attract each other in some way. Alright, if they have really, really weak intermolecular forces, like the boring old London dispersion forces, then they're not going to be hugely attracted to each other, and it's going to be easier to get the kinetic energy to, bounce away and things like that. Whereas if you have really strong intermolecular forces, like, say, hydrogen bonding, then it's going to be hard. It's going to require a lot of kinetic energy to get these things to break away. Alright? So if there are strong molecular forces, you are more likely to be towards the solid end of the range. there's really weak intermolecular forces, you're more likely to be a gas, or closer to the gas range. Alright, so solid is going to be more likely to have strong intermolecular forces. Alright, so the intermolecular forces are also going to affect how much kinetic energy you have to put into something in order to get it to change state and melt or evaporate. Molecular mass also affects things. Alright, so the larger the molecules are, the more slowly they move. It kind of makes intuitive sense. Like, you don't really see elephants running across the savannah real quickly. Alright, cheetah's a lot smaller. So, if something has huge molecular mass, that's going to decrease its kinetic energy and make it more likely to be solid at room temperature. If it has very little molecular mass, it's going to be more likely to be a gas. So, of these three choices, which one, just knowing its molecular mass, knowing nothing else about it, which one would you say is most likely to be a liquid? So, hoping you're thinking, well, solid's going to have the biggest, gas is going to have the smallest, liquid is going to have somewhere in the middle. Alright? And then the next thing is molecular mass can also indicate relative boiling points. Alright, so boiling point is the temperature at which a substance evaporates. Alright? So essentially how much kinetic energy you need to evaporate the substance. So which one of these is going to need the most kinetic energy to evaporate? Alright, so you can also kind of think of it as which one of these most strongly wants to be a solid and is going to take a lot of energy in order to get the molecules to move apart. And that would be B, the one with the most mass. Other factors that determine state at room temperature are the shape of the molecule. So this is substance A, that's B, that's C. Alright. The more flat and uniform the shape is, the more closely the molecules can line up with each other. So like, this one, if it had a neighbor that had the exact same shape, they could get real close. Whereas this guy, down here, to actually kind of interact with a neighbor, like, there's got to be some distance between those two. Alright? So the more closely they can interact with each other, the more likely intermolecular forces will work. So uniform, simple shapes that can closely interact are going to have stronger intermolecular forces. So of these choices, which one do you think is more likely to be a solid? Strong intermolecular forces or weak ones? Alright, these guys are going to line up right next to each other and interact real strongly. These guys with the branches are going to have issues doing that. So if there's branching, you're more likely to be a liquid or a gas. If it's real nice shape, straight and even pattern, then you're more likely to be a solid. Alright, so those were things that were just kind of honestly apply to gases, liquids, and solids. But based on your quiz, there is a little bit of information you want to know directly related to solids. Alright, so solids have, we kind of talked about this, significantly less movement between their atoms. They just slightly vibrate. Alright, and solids are defined by their shapes and their bonds. So you've got two major kind of solid shapes. You've got crystalline solids, which are very organized and have a repeating pattern. Or you have amorphous solids, which kind of have no shape. And it's more of a random structure that builds them. Then most solids tend to have that crystalline shape, and just to kind of demonstrate that uniform structure that they have, this is called a unit cell. Alright, And you can see in here, it's very, very organized. It's like a cube. Alright, so what are the angles between the atoms here? What kind of angle does that look like to you? Hopefully you are thinking a right angle, so 90-degree angle. Alright, and how about the distance between the atoms? What do those all seem like? They're variable differences, or are they all pretty much the same? Especially because everything on here is making a nice little uniform square. Distances are all the same between the atoms. Hint, 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 hint. Then the last thing you want to kind of write down, just because I know you're going to have questions about it, is the 4 types of bonds related to crystalline solids. Alright, so there's ionic bonds, which is, you remember from last time you had me, that's a metal bonded to a nonmetal. They always have those like highly, highly organized crystalline shapes. There's covalent network, which is all nonmetals, but they're also pretty highly organized. There's metallic bonds, which are actually just all metallic atoms. And there's a little less organization to it, which is why metals are kind of so malleable and you can change their shape and things like that. And then there's covalent molecular, which isn't really exactly a bond, but it's the intermolecular forces between the molecules, and that's going to be the least organized out of all of these 4 crystalline bonds. So, hope you got some good notes out of this. You are ready for that 1.14 quiz.